Assalamualaikum and welcome back. Let's proceed to example 3 where we are asked to use triple integrals to find volume of solids bounded by the given surfaces. Okay, let's look at example 3 item 1. So here we are given 1, 2, 3, 4 equations. So those equations represent surfaces where the solid is bounded. Okay, everybody knows z equals 0. Z equals 0 is just the xy plane. So it's horizontal. Y equals 1 is a vertical plane, and y equals 2 is also a vertical plane, and z equals 9 minus x squared is really a parabolic cylinder. But let me refresh your memory on how to plot that. Okay, so here we have z equals 9 minus x squared. So in 2D, this is just a parabola. In 2D, z equals 9 minus x squared is a parabola that opens downwards, and it intersects the z-axis at 9, and on the x-axis it intersects at 3 and -3. So when you look at the equation here, it doesn't have y in it, meaning that it doesn't matter what y is, you still get the same parabola shape. So let me plot a few parabolas on a few y equals a constant plane. So let's say here we have, this is y equals 2 plane. So that's a vertical plane. And here we have, that's 2, so probably that's a 1. So let's say this is y equals 1 plane. Okay, so here we have y equals 1. And here we have y equals 2. And here we have, this is on the xz plane. So we're going to plot that on the same, on y equals 0 plane. So we have, it intersects the z-axis at 9. On the x-axis, it's intersect at 3 and -3. Okay, so we're going to plot the parabola here. But do note that I don't sketch the parabola below z equals 0 axis. Okay, because we have this z equals 0 as one of the surfaces, one of the boundaries. So we don't draw below that. Okay, all right. And then we have the same shape on y equals 1 plane. So we have, excuse me, we have another parabola. And on y equals 2, we're going to sketch the same parabola, the same shape of parabola. And then we're going to connect them. So from here, we connect the parabola. What we get is a parabolic cylinder. Okay, so this is a parabolic cylinder. But as you can see, this cylinder we can draw this a bit further to the right, and we can also draw this a bit further to the left, and also below the z equals 0 plane. But I don't do that because we have z equals 0. That's one of the boundaries. And we have y equals 2, so it doesn't go beyond that. So, and then we have y equals 1. So when we slice this parabolic cylinder with z0 plane, y equals 1 plane, and y equals 2 plane, then what we have is something like this. I'm going to sketch this a bit more. All right, so we have y equals 1 here, and let's say this is y equals 2. All right, so we only sketch the parabola on y equals 1 plane, and also on y equals 2 plane. So this is our solid. Okay, so our solid is this shape. It's a parabolic cylinder, but on the right we have y equals 1 plane, no, y equals 2 plane, this plane there. And then on the left we have y equals 1. And at the bottom we have z equals 0. And then on top we have the parabolic cylinder, which is z equals 9 minus x squared. So those are our the surfaces, the boundaries of the surfaces. the surfaces of the solid. Okay, all right, so now we want to find the volume. Okay, so from before, we know that for a volume of a solid, we need to use this formula here, where we have, this is volume. Okay, volume is equal to triple integral, so volume from the formula, volume of a solid is equal to dV integrate over solid G. Right, so now we need to figure out how to evaluate this. What is the iteration of dV? Is it dx, dy, dz, or another path combination? All right, so obviously our solid is not a cuboid. Okay, so we cannot use this, this bit here where it can be done in either way, the iteration, but because it's not a cuboid. So now let's look at this shape, this solid here. And this is, we can project our solid G onto the xy plane. So if you project our solid G here on the xy plane, what we have on the xy plane is a rectangle. So that would be our region R, which is on the xy plane. Or I'm going to sketch this separately on the xy plane. Oops. Okay, so here on the xy plane, we have a rectangle. Okay, so here we have x-axis, x-axis, and here we have y-axis. All right, x is from, here we have -3 to 3, so here, this bit here, that's 3, that is -3. So x is from -3 to 3, so let's say this is, oops, it's ugly, oh well, say this is -3, and here we have another line where we have x equals 3, and here we have these two lines, y equals 2 and y equals 1. Okay, so here we have y equals 1, y equals 2. Right, so this is our region R. Okay, so if we do that, if we project our solid G onto the xy plane, which means that we have to evaluate this by integrating our triple integral with respect to z first. Okay, with respect to z first. All right, now let's figure out the upper and the lower limits for z. All right, so the upper limit for z would be the top boundary. So here, that would be the top surface. So in our case, the top surface would be this parabolic cylinder, okay, which is governed by this equation. Okay, so the upper limit for z is going to be 9 minus x squared. And the lower limit, which is the bottom surface. So the bottom surface is exactly on the xy plane, which means z is 0. Okay, now we need to figure out our dA. So dA here can either be dy dx or dx dy. So we just refer to our region R, which is on the xy plane. So in our solid, our region R is a rectangular region, which means that it can be done in either way. So the order here does not matter. It can be dy dx or dx dy. So let's say we stick to dy dx. So x here is going to be from -3 to 3. Okay. And y is going to be from 1 to 2. Okay, so that's how you get the limits. All right. Now the evaluation here is the easy part. Okay, so here we need to integrate the inner integral first. So the inner integral is integration with respect to z. So integrate 1. So here the integrand is 1. So integrate 1 with respect to z. You get z. And then replace z with upper and lower limits. Still have dy dx. Okay, replacing z with upper and lower limits, we get 9 minus x squared minus 0. So we have that. Okay, so now the next integration is with respect to y. Okay, so here we integrate 9 minus x squared with respect to y. But you know, when we integrate with respect to y, we consider x as constant. So we get 9 minus x squared considered as constant. So we have y here. And then replace y with upper and lower limits. Okay, so from there we get 9 minus x squared. Then upper limit for y is 2, lower limit is 1. So we get 2 minus 1, which is 1. So we end up with 9 minus x squared. Alright, so now the last integration is with respect to x. So integrate 9, we get 9x. Integrate x squared, we get x cubed over 3. And now replace x with upper and lower limits. Okay, replacing x with upper limit 3, we get 9 minus 9 times 3, which is 27. And here we have 3 cubed over 3, that would give us a 9. Minus the lower limit, replacing x with negative 3, we get negative 27. And here we're going to have plus 9. Okay, so simplify that and get 27 plus 27, 54, minus 9, then you get 36. So the volume of the solid is 36. So in this case, we project our solid onto the xy plane. So the first integration should be with respect to z, and then figure out what is the upper and lower limits for z. So that would be the top surface minus the bottom surface. All right. Next example, we have item 2. Well, for item 2, I'm going to leave you to this. I'm going to leave you to solve number 3, item 2 yourself, because this is what you get here would be a tetrahedron, which is similar to example number 2, except now your function f(x,y,z) is just 1. So I'm going to let you solve this, figure out the upper and the lower limits. It's very similar to example 2. And example 3, item 3, I'm going to leave that in our next video. Thank you.